You said. Hey, if we can turn to page 30. Um, let's look at, I think we got through a good chunk of particle motion problem. Let's just finish up with G and H. So G says, is the velocity increasing or decreasing at t equals 2? So we know that this is really talking about, it's not talking about velocity, it's talking about the slope of velocity, which is really just acceleration. So we just have to find acceleration at 2 and use that to make our conclusion. So if I plug 2 into acceleration, I get 8 minus 4, which is 4. So since acceleration is greater than 0, this is basically telling me that the slope of velocity is positive. So if the slope of the velocity is positive, that means my velocity graph is rising. My velocity is increasing. Part H, find the velocity and position when acceleration is 0. Well, we gathered that acceleration is 0 at t equals 1. So we can just plug 1 into velocity and position and find the velocity and position at those moments in time. Okay. You guys can cross off 7 and 8. I won't put limit definitions on your test. Okay, number 9 is find the points at which the graph of the equation has a vertical or horizontal tangent line. So we have to look at we'll build our derivative using implicit. And then to find the horizontal tangent line, what's our strategy there? Set what? Numerator of derivative equal to 0. And it's asking for points. So whatever we solve for, we still have to plug back into the original equation to get the full order pair. And what's our strategy for vertical tangent? Denominator of the derivative. Okay, good. All right, try that. See if you can go through your steps. You guys can check your progress with page 32. The key is on the back page, back of your packet. let's walk through this problem here. We go through power rule for each of our terms. 4x squared becomes 8x, y squared becomes 2y, dy dx. 8x becomes 8, 4y becomes 4, dy dx equals 0. Right? Our original equation showed two different places where y shows up. We're expecting two dy dx's to show up. And from here, we're just trying to collect our dy dx terms and solve for dy dx. So group my dy dx together, factor dy dx out, divide over. I decided to clean up, but you don't have to. You can leave your answer as 8 minus 8x all over 2y plus 4. I just decided to factor and use smaller numbers. So you don't have to reduce your derivative fraction. You can still get to everything you need to find. So now to find the horizontal tangent, we can set the numerator portion equal to 0. Now the numerator is in terms of x. So x equals 1. I'm trying to find the full location of these horizontal tangents. So I still need to find the y value. Right? Anytime I'm looking for a location, I have to use the original equation. So replace all the x's with 1s and see what the y's gives me. Y gives me 0 and negative 4. So those are my order pair, 1, 0, and 1, negative 4. Find vertical tangent. We set the denominator equal to 0. The denominator just happens to be in terms of y. So we set y plus 2 equal to 0. Or if you had 2y plus 4, that's fine. If you set 2y plus 4 equal to 0, you'll still get y equals negative 2. But remember, y equals negative 2 is only partial information about the vertical tangent. We want the full order pair. So back into the original equation it goes. And we solve for x. Now, this problem is only asking for order pairs, and we provided all the order pairs where these behaviors occur. But let's say the problem says find the actual horizontal tangent lines and the vertical tangent lines. If that's the case, then let me just identify what those would be. So your horizontal tangents would be your line equations would be y equals 0 and y equals negative 4. Right? Those will be the horizontal lines that's actually going to skim the surface of the curve and have a slope 0. If I want to find vertical tangent lines, then I want to create vertical lines that goes through those points. So your lines will be x equals 0 and x equals 2. So I want to make sure that we understand that when we're going through this process and we're solving for x and y, we're just looking for the locations where these behaviors exist. But if we're actually asking for equations of lines, they will have to look like y equals 0 and y equals a number to be horizontal lines, and x equals a number and x equals another number to be vertical lines. So they kind of seem confusing because sometimes if you solve for x, it's just the one piece of your order pair, but then y equals and x equals can also represent the actual horizontal and vertical lines of graphs. Okay, let's go to page 33. And let's try number 2 and 3 on page 33. So page 33. Find d2y over dx2. What does that notation mean? Second derivative. Okay, so one thing at a time, though. Let's find first derivative. So to find the first derivative, what process would you go through? Okay, try that. Okay, so this is my halfway point, 5 over 3 minus x quantity squared. Any questions with that? All right, careful that we don't reduce when we can't, right? We can't cancel these 3 minus x's out. We just have to spend the time to clean up the numerator. So next up, there's two options. If I want to find the second derivative, we can either go through what? Quotient rule again, but there's only a constant up here. What's another option besides quotient rule that we can do? Yeah, let's bring that denominator up because that 5 is not really, it's just it can just be a coefficient. It doesn't have to be its own thing. I mean, it's not wrong if you go through quotient rule, it's perfectly fine. I just want to offer the possibility that that we can go through chain rule, especially if you have a fraction and either your numerator or denominator is missing a variable, then I typically want to, that's my preference. I typically want to avoid quotient rule if I don't have to go through it. But if I have a variable up top and variable below, that does force my hand. But typically I like to avoid quotient rule unless I'm forced into it. So here, if I just bring that 3 minus x to the top, I can just go through chain rule instead. So outside, inside, and we take turns with each derivative. Okay, outside's derivative, 5 parentheses to -2, that becomes -10 parentheses to the -3. Let's just do power rule for that outside portion. The inside stays intact. We don't want to do anything with that inside just yet. Times, now we're ready for the inside's derivative. 3 minus x becomes what? -1. -10 times -1 is just 10. I'm going to push that parentheses back down to the denominator. You'll get the same thing if you went through quotient rule. And I have that worked out on my key if you want to see that. Any questions with 2? All right, number 3. Find dy dx. So we're just finding the first derivative here. 3x plus 1 all over 1 minus x squared, all raised to the third power. This is a combination of rules here. What's involved if we want to find the derivative? Chain rule and chain rule and quotient, right? Which one comes first? So the way that you can decide is you look at the parentheses, and well, you ask yourself, which has a larger impact on the problem? Does the chain rule see more of the problem, or does the quotient rule see more of the problem? And here, chain rule is going to see more of the problem because the parentheses over everything, and what's inside the parentheses is going to be the chain rule. So sorry, is the quotient rule. So here's the easy way to tell. If your parentheses is over everything, then chain rule comes first. But if your parentheses is only over a portion of the problem, then chain rule comes second. It's going to be the other rule that gets applied first. All right. So here we want to do chain rule first because parentheses is over everything. Okay, outside's derivative, 3 parentheses squared. Keep the inside. Times, now we're ready for my whole inside's derivative, which I have to go through quotient rule. All right, we'll do some cleanup here. I do want us to get it down to a clean fraction. So this is really where my work is in terms of cleanup. So I'm going to step to the side here and see if I can. If I move this negative 2x in front of the 3x plus 1, then I can just merge them to be positive 2x, and then I can just distribute the 2x through the 3x plus 1 all at the same time. All right, so now this is my cleaned up numerator above my fraction there. So let me see if I can get my derivative to just be one fraction. So numerator, 3 goes there. 3x plus 1 squared, that goes in the numerator as well. This is the cleaned up version of my numerator mess. In my denominator, I have a bunch of 1 minus x squared. How many do I have in total? One minus x squared raised to what exponent? It looks like 3, but it's actually what? 4, right? We have to make sure we pay attention to this exponent. This exponent is seen both in numerator and denominator. There's 2, a 1 minus x squared. There's 2 here. So add those two numbers together, we get 4. Okay. Any questions there? Okay, page 35. Okay, number 1 says let h of t equal to f of g of t, find h prime of 1. So f of g of t, if we want to find the derivative, what do we have to go through? Chain rule. Okay, try that. See if you can get your chain rule to show up. after you build your derivative, replace every t with 1. Take the time to eventually get this out of function notation, but you know it's a multi-step process. You're not going to be able to just find one number and be done with it. We got to do this one piece at a time. So find g of 1 first. That'll give us more clarity as to what we're looking for in the big picture. F prime of 1, are we good up to this point? F prime of 1 times g prime of 1. Okay, so F prime of 1, what is that asking for? Slope of the F graph at 1. Now, this isn't very good diagram in terms of, we can interpret it both ways, right? If you look at to the left of 1, it looks like a slope of 2, but then to the right of 1 looks like it changes to a slope of 1. So you won't get something like that on the test. It'll be very clear. It'll be a straight line. It won't be a straight line followed by a curve. But if this were on the test, you can do whatever interpretation you want. You can call it 2, you can call it 1, but essentially you're finding the slope here. Okay. On my key, I said the slope of 1, but you could say 2. G prime of 1, though, what's G prime of 1? Oops. This is definitely a slope of what? -1. Yeah. So if you have your answer being -2 or -1, that's fine. But yeah, it'll be clear on the test. You won't have something that is vague. And if it is vague, I would be flexible and allow any interpretation. All right, number 2, z equals f of t times g of t. Find z prime of 3. This case, we have to go through what? Yeah, this one is product rule. Yeah, you see 2 t's that indicates you have 2 different functions. This is a function within a function. There's only one variable. Well, there's only one t or one x. Okay, try that. Try number 2. Okay, f prime g plus f g prime. Replace every t with 3. And then you're just off to looking for either y value or the slope of your g and your f graph. All right, any questions? All right, let's try number 3. Number 3, we're asked to find the derivative. So what's involved in this process if we want to find the derivative? Implicit. How many dy dx's do you expect to show up? 3. Yeah, I have 3 places where I see y's. I should be eventually, when I find my derivative, I should have 3 separate dy dx's. Okay, what else do we have to involve here? Product rule. Yep, 6x squared y. There's definitely multiplication between variables. I have to go through product rule there. Okay, try that. And then your goal is to try to find this. This is your end goal. You're trying to get to this dy dx. Okay, so see if you can go through your steps and eventually work towards your goal dy dx. F prime g plus fg prime, that's 6x squared y becomes 12xy plus 6x squared dy dx. 2y cubed becomes 6y squared dy dx. 24x, negative 12x squared becomes negative 24x. 6y becomes 6 dy dx. 1 goes to 0. We collect all the dy dx terms on the same side, the non-dy dx terms on the other side, divide it all over. And here I can take out a GCF of 6, a GCF of 6 below as well. I can take out all the 6's. I'm left with 4x minus 2xy. Thank you. Okay, thanks. All over x squared plus y squared plus 1. Any questions? I want to do a part B for this problem here. How would you do this? Find the equation of the tangent line. At 1, 1. So 1, 1 is your order pair. How would I find the slope? Plug 1, 1 into the, yep, into your slope formula. Is your slope formula, right? Your derivative. And then from there, you can do a point slope form. Right? Okay, any questions? Okay, go to the very back of your packet. There's a blank page, and I want you to copy this problem down here. This is like the problem that we worked on yesterday where you have to solve for A and B, constants A and B. And our strategy is set the equations equal to each other, and then also set the what? Derivatives equal to each other, right? They'll give us two equations to work with, and then we can use both equations to help support and solve for A and then solve for B. So see if all this makes sense from what we did yesterday. Right? And then both sets of equations, we're replacing every x with what? 2. Yeah, because that's the potential breaking point of our graph, right? That's the x value in question. We want the connection and the smoothness of the graph to exist at 2. So this is as far as I can get on the equation side of things. Any questions up to this point? Our next stage is setting the derivatives equal to each other. So what's the derivative of my first term here? The 1 goes to 0. This term becomes what? Okay, plus. Okay, equals a 0. Good. So the only derivative, the only thing that comes out of ax plus b is just a and just a, right? So we set the two sets of derivatives equal to each other, replace every x with 2. And in this case, I get negative 2b plus 4 equals a. Doesn't quite allow me to solve. I'm not able to solve for a cleanly just yet, but I can make a substitution, right? A equals negative 2b plus 4, so I can just plug this into my first equation. Right, substitute one variable in for the other. So if I'm deciding which variable to solve for, I'm always going to go down the path of least resistance. So here, the a is the easiest one to get by itself. I don't deal with any fractions. So if a is equal to negative 2b plus 4, I can go to my second equation, replace the a in the second equation with negative 2b plus 4, solve for b first, and then turn around and get back to my a. Okay, any questions? Okay, turn to page 39. So page 39, 40, 41, it says worksheet number 4. And then immediately after that, I've got the key attached. So this is worksheet 4 is what I'm going to be doing tomorrow as morning review. It's got everything. This is the full review that I encourage you guys to use as your kind of your mock test. If you have time tonight, work through this, see how well you do. And if you can do well without much with many issues, then you should feel pretty good about tomorrow. So I encourage you guys to do that. If you do that, then tomorrow you can come in and if you want to still come into the help session, you can get those questions answered. Or if you don't have time, then at least try to do the worksheet with me tomorrow morning. I'll have a help session tomorrow at 7:15. So I'll send out a link through Teams if you want to join virtually. But if you look at my website and scroll down to 2023, I did record this for last year. So if you want to work through it and watch that video from last year, you can, but I'll also be recording it, but you guys take the first period. So, but yeah, I really think this is going to be your best way of preparing for the test. Do this worksheet. If you feel good about it, you should feel good for tomorrow's test. Okay. Make sure you bring your calculators. I'll send a reminder this afternoon. Okay. And again, worksheet 4 has everything you need to prepare for your test. All right, can we get your phones? Yes, yeah. I'm going to send a reminder for you guys to bring your calculator tomorrow. Yes. I'll unlock that room so you guys can use that.
I feel like she'll get we just tonight.